That's what I got. So today is the last day of the unit, which means next time we review and we test. Excuse me. Senior test is happening soon. On a Tuesday, previously you guys got through the Tuesday. So please do not plan on any question time on Tuesday. If you need questions and your homework questions answered, you need to come in before then. I will be working today after school in the math lab down in Mr. Christensen's room. If you would like to work on any of your homework packet then. Or I'm available after school tomorrow. I do have a little person who's okay, anyway, so my son will be here after school. I should be here right after school. Yesterday we were moving stuff, but he's walking today, so it should be far away. I don't know. Okay, so the moral of the story is if you need help, please come in. Okay. Here's what a relation does. Here's the picture. A relation is just a way that we're going to match points together. So if I tell you that this is the relation and 1.2 goes to the 1, 1.4 goes to the 1, 1.6 goes to the 2, 1.9 goes to the 2. If I wanted to do the inverse of that, all I have to do is switch the domain and the range. And now the domain goes out to the range in the inverse manner. Is that okay? So anytime we do the inverse, all you have to do is switch the x and the y. That's kind of the big first thing that you need to know. And it says it right here, that AB is in the ordered pair of the relation, and BA is the inverse. Okay, so number one, this diagram compares relation R with its inverse. Compare the relation with the inverse. How are they alike? How are they different? So we just said what? They're using the same set of numbers, except x and y are switched, right? The domain and range are switched. Is the relation a function? Well, in order to determine a function, we need to know in order for it to be a function, for every value in the domain or for every x value, there is only one y value. So that means if it's in the domain, a number can't be split to two different numbers. So this 1.2 goes to the range, that's okay. Does the 1.2 go to another number? No. And the 1.4 goes to the 1, yeah, that's fine. Does the 1.4 go to a second number? No. 1.6 only points to one number and 1.9 points to one number. It's okay that they point to the same number, but it's only matching up to 1, right? Then I would say that yes, this is a function. Because for every one x value, there is only one y. But what about the inverse? For this one, does it point to two different numbers? That means this is not a function. If I were to graph this, at 1 it's at 1.2, and at 1 it's at 1.4, it would not pass the vertical line test, right? Because you got 2 points right next to each other, and at 2 it's 1.6, and at 2 it's 1.9, it would not pass the vertical line test. So that is not a function. I think that answers your question. Any questions with that? So if I were to show you this, let's see, after that, it looks like this. 2, 7, 9, 2, or 4, 1, 4, 2. Would that be a function, yes or no? No, why? Somebody else tell me, is that a function, yes or no?
No.
No, because for every x value, there's a point in only one line. What about this?
Yes.
If it looks like this, could it be a function?
No.
No, good. What if it looks like this? Could it be a function?
Yes.
Yes, that's fine. Okay, moving on. To find the inverse, I guess you just wrote this down this right here. To find the inverse of a relation or a function, you switch the x and the y values. So if I gave you this relationship and I wanted you to find the inverse, what would it be? Well, all of my x values come over to y. And all of my y values go over to x. Part of your homework tonight is graphing these. If you have a second color to use, it may be worth your time to graph the relation in like blue and the inverse in green, but I really don't care. So, I really don't care if you do it. So the relation is 0, -1, 2, 0, 3, 2, and 4, 3. Any questions with that? Now if I wanted to graph the inverse, we switch the x's and the y's. So the inverse is -1, 0, 0, 2, 2, 3, and 3, 4. And what will happen, I know, if you were to put this line in there and flip them over, they would be in the same location. You see that? I don't know why, that's very like pleasing to my, I don't know. I really like that. If you were to flip them over there, it should look mirrored. I just wanted you to notice that they should always kind of like expand across the line. So on your homework, I think you have 2 that you have to do this in. Will you try those 2? Problems 1 and 2, please. When you're done, give yourself a point. Right. Leave it here, so skip this one. When you're done, give yourself a point and let's move on. Okay, let's move on. If you're given a set of points and you want to find the inverse, you just switch the x and the y values. That's what you just finished doing, right? The same is true if you're given an equation. If I'm giving you an equation and what we're doing today. What's the point? So, if on this, let's start with part B. It's a little bit easier. Keep that right here. So, if I want to find the inverse of each function, you're going to look at the function and switch the x and y variables. So instead of this, I'm going to say x equals 4 minus 3y. Then, I take the function and solve for y. So what's the first thing you would do? Subtract the 4. You've got x minus 4 equals a negative 3y. And then do what?
Negative 3.
Good. So y equals 4. Now let's talk about the domain and range of each piece really quick. What would, or at least the domain. Let's talk about the domain on this one. Is there anything that x can't be? Let's not talk domain range. We will in a second though. Is there anything though that x can't be? Am I restricted in any way here? Or right here? No. Okay. Let's look at part A now. So I want to find the inverse. What's the first step? Change the x, y. So it's going to be x equals y squared minus 1. And then how do you solve for y? The first step? Add 1. Good. And then you do what? Take the square root. Raise your hand if you know. Every time you are putting the square root on, what do you need in front of it? Raise your hand if you know. Oh, raise your hand if you know. Lindsay. A plus or minus. Good. If you do that, you get a point and Lindsay gets 2. So y equals plus or minus square root of x plus 1. Now really quick, in the function, is there anything that x can't be? In the function? No, there's nothing that x can't be, but in the inverse, is there anything that x can't be? Yes, I would have a domain issue on the inverse, right? Okay, let's move on. I'm not worried about what it is, I'm just saying that there would be one. We'll talk about what there would be in a second. Try part D on your own, and then we'll work on homework problems. Part D. Nope, that's what the basic because we will need to start it. Yeah, so when you solve for y, did you switch x and y? Oh, you got switch. Or you can solve for x and then flip it at the very end. Is there a plus or minus on this one? So on this one, you would subtract 5. What would you do next?
Wouldn't you switch it from y next?
So yeah, first thing you want to do is switch the x and the y. And then subtract the 5, right? And then what?
Square it.
Square it. I know it looks funny, but I just missed 5. And then what?
Add 1.
X minus 5 squared equals y minus 1, so if we add the 1. Okay, in the original function, is there a domain restriction? Yes? Is there anything that x can't be? No. Because of the square root, there's going to be a domain restriction, right? It can't be anything that makes that 0. What about in the final answer? Is there a domain restriction there? No. Okay, I think on the next page, we'll move on to the next part. Yep. So on your homework, there's about 8 of them, okay? For you to try. Take 4, 5, 6 minutes. You're just going to give it a friend can and then take roll.
Yes. I just took roll, so remind me to change it. Okay, can we look back really quick on Where did I put it? On these functions. Oh, I'm still frozen. There is a part
of this text box that I didn't read, which starts right here. So it says if the inverse of a function is denoted by f, hold on. Normally when we write a function as simple as this, remember when we were doing trig and we were doing inverse sine, inverse cosine, we had a little -1? That -1 indicates that it's an inverse. So the same is true as this. How do you tell between this y equals and this y equals? You could rewrite, instead of saying y equals, you can say f prime of x, or f inverse, or the inverse of f prime, one of those. So you also could write like this. In fact, starting right now, whatever problems you haven't done, will you write your inverse function like this? So on this one, we have y equals yada yada yada. Instead of y equals, I want it to be what? F prime of x. I'll either the -1 or I guess up here it just has a little tick mark. So either the -1 there, I would say it's really true just to have a tick mark. F prime, either the -1 or a, so that would indicate that I'm talking about the inverse. Is that okay? So whatever ones you haven't finished on the homework, if you open mark something like that, F prime. Alright, so core 3 more minutes
Somewhere in there, a couple more. That's a good question.
The f of x already usually put y, right? So then we'll use equal.
All right, Aubrey, I fixed that. You're welcome. Oh, except for I never stopped recording, so all your pictures are now on the recording.
You're welcome.
I froze it. It's still recording.
Okay, what's the problem that you were asking? Can you read it to me? It's like 7x minus 7x minus 3 over x. It's actually a really good question. Everybody please look at number 11. The getting y by itself is a little bit trickier on this one. So let's look at it. The very first step is still to switch the x to y. So when we do that, we get x equals 7y minus 6 over y minus 1. Now you have to get rid of the denominator. How do you cancel out that y minus 1? You're going to multiply by y minus 1. Good. So then the y minus 1 and the y minus 1 will cancel. And now you've got y's on both sides and some weird things happening. The first thing I want to do is get rid of the parentheses. So how do I do that? Okay, let's distribute by x. So this would be xy minus x equals 7y minus 6. Any questions with that? You can move it up. Any questions with that? Now, in order to get y by itself, the next thing that you would have to do is move all y's to one side and everything that doesn't have a y to the other side. So I'm going to keep this here. I'm going to subtract the 7y, so it moves it over here. So it would be xy minus 7y. Is that okay? Good. Is that okay? Then I want to take that minus x and move it on this side. So let's add the x over. So this would equal on the right, what? X minus 6. Is that okay? Moving everything that had a y to one side. Oh, bless you, bud. You need to go get a drink, Brandon? Go ahead. Okay. Everything that has a y to one side and everything that doesn't have a y to the other side. Is that okay? Now, these both have y. Could you factor a y out? So then you're left with x minus 7. Is that okay?
Whoa.
Now, how is that x minus 7 connected to the y?
I multiply, so how do I cancel the multiply?
You get 5.
Divide by the x minus 7. So my final answer would be f prime or f inverse of x equals what? X minus 6 over x minus 7.
I ran out of space somewhere along the line there.
Right small.
Okay, you mark 6. Keep going. Is there another one like that? Do you get more practice? Any others that are having some like
Whoa.
if you have, I think at one point you're going to have this. And one of the problems, have you seen that yet?
Yeah. That's
How do you get rid of the 1/2? Rather than dividing by 1/2 and then making it confusing over here, what's another way to cancel?
Multiply by 2. So if I times both sides by 2, would it cancel out the 1/2? So you're left with y, or f prime of x, equals what? So when you see that, rather than dividing by the 1/2, let's multiply by 2 to cancel out that. All right. Give 30 seconds. I don't know.
Okay, so you got this on all of your whiteboards and okay, so are you awake still right there?
All right. Now there is part of those 8 problems that we were just working on that we didn't cover yet, and we will in just one second. there to determine if it's a function or not. So, if you'll flip the page on your notes,
Last page of notes.
this is the very, very last. Fantastic. So, on these notes,
For the rest of the year.
this blue graph is the graph y equals x squared plus 1. Is this blue graph a function? Yeah. For every, does it pass the vertical line test? Yes. I know what vertical. Okay. It passes the vertical line test. Now, when I take this function and find the inverse of it, let's really quick find the inverse. So it would be x equals y squared minus 1.
Add 1,
Add
square
1,
root it, plus
and
or
then
minus
square
the square
root it,
root.
plus or minus.
That's like with 7 points right there.
Sweetheart, I already told you this is going to be a no graphing calculator test. So as you're doing your homework, you may want to, I'll give you strategies though on how you can get around the graphing calculator. Okay, now, because of the plus or minus, now remember when we were doing the parent function, the square root graph only looks like this? Is that okay? Because of the plus or minus, that adds the other half of the parabola back on. Now, is this a function?
No.
No, because it doesn't pass that vertical line test. So the only time on those problems that your inverse would not be a function is if you have this sort of situation. So if you look at your homework for the next one of those have a plus or minus square root, any of them?
Yes. 8.
So number 8 is not a function. Number
12.
12 is not a function. Everything else will be. Because that plus or minus square root is the only time that the inverse would not be a function.
You don't have to draw it, right?
You don't have to drop, yes. What about 7? And 7 is also not a function.
Pretty rough, yeah.
So, recap, 7, 8, and 10?
12. 12.
7, 8, and 12.
Oh.
Right, you didn't have to do 9 and 10. Oh.
9 and 12 are 9 and 10 are extra credit. You got to find them first.
I did all of that. I still want to do it. It's still a relation. I still have a relationship between my x, y values. It's just not a function.
Just write that.
What? That it's a relation? No, I just want you to write that it's not a function. So add my answer together, and I'll find you that. So when I explained it, I said no plus or minus square root, and I drew this in my explanation.
What was number 8 again?
It's not something, but it says the plus or minus, it's not a function. It's the plus or minus.
So basically, I can write something like that.
There's two parts to the answer. One is no, not a function. The other is that.
So there's one for number 3 you did right now. Why is that projected shape? That's like,
I don't know. I think that they got a wrestling match in their English class every day. I'm not sure. It's really
I just can tell there's one kid that just like,
right. That one was really nice. It shakes through like on the desk. It keeps your desk over and over and over. If you do that, I didn't think you learned all that. I didn't think that you really knew it. Oh my gosh. Okay, moving on. Now, is it necessary? Well, let's look at part B, or number 5 really quick. How to graph this? What shape does this take? Is it a parabola? Is it a square root? Is it a line? It's a line, right? Now, it's not really in the line form. I wanted mx plus b would be like this, right? So when I'm graphing a line, I start with the x-intercepts, and then how do I find my next point? I use what to find my next point? Raise your hand if you know. Or if you have a guess. Raise your hand. How do I find my next point? I have to find intercept. How do I find the next point? This says. The slope. Good. Just so you can see points, everybody else can find that means that it was the slope. That negative 7 7 means I count down 7 and go over 1. Count down 7, go over 1. Something like this. Okay, now, do you have to know, so this question says graph the relation and its inverse. Do you have to know the equation of the inverse in order to graph the inverse?
Nope, you just flip it down.
Okay, before we do that, plug in, guys, really hard, really relaxing, really irritating. Okay, before we move on, let's find the domain of this. What's the domain of this equation? What x values can it take? Anything, right? Line. The domain is all real numbers. What about the y values? The range. What's the range of that function? What y values can it take? Matthew? Yeah, good. All numbers. That's the point. Okay, so it goes forever left and right, it goes forever up and down. Now if I'm talking about the inverse, so my blue is inverse, so domain is prime, and the range prime because of how we mark the function. The domain and range, remember from the very first page, we can switch them. So the range is the domain, and then range, I don't know how to do that, give me a second. If I want to find the domain and range for the inverse function, I just have to switch the domain and range from the regular function. So the domain of the regular function is the range of the inverse, and the range of the regular function is the domain of the inverse. Does that make sense? They just switched. Likewise, sorry, what?
So that would go from positive 32.
Sorry, what? Hold on just 1 second. Now, these points, let me just switch that to my minutes. What are the points that I plotted? The xy points. I'm sorry, it's not ordering. One of the points I plotted were 0, 3, right? And then the other point was 1, -4. I don't have to know the equation of my inverse when my goal is just to graph it. If I know the points of the regular function, could I switch them for the inverse? Yes. So I don't have to find the inverse function unless it asks me to. But the goal on this question is just to graph. So I just have to take the xy points from the regular function and put them, and we have the other one. So my inverse function will look like this: 3, 0, -4, +1. I'm going to draw those. I use the same number on the side. Yep. Likewise, just as before, it's kind of harder to see when you're dealing with, it's kind of harder to see when you're dealing with lines, but if you were to flip those across this line, it would be the same thing, they'd be in the same spot. Just like this line's right here, and I would flip it over, it would be right here. This one's right here, and I flip it over, it's right there. Now, when it's a line, it's not that hard to find the inverse. Okay, you switch this and how you find it. When it's a parabola, it gets a little bit more difficult. So first of all, let's graph the original equation. Where's the vertex? What does the -3 do? What does the -1 do? So over 3, up or down? Down. If you do that, give yourself a point. The pattern here is over 1, up what? 1. Over 2, up 4. But I take off my ups and do what with it? Good. So from this point, over 1, up 2. Over 2, up how many? 8. Put this right here. And right here. Is this a function? Is that a function? Yes. Good. Let's plot. What are my xy points for this function? What did we plot? We said 1, 7, 2, 1, 3, -1, 4, 1, and 5, 7. Why do I care about those plotted points? Because normally I really don't care. If I was just graphing that equation, I wouldn't really care about those points. Why do I care this time? Because I'm going to have to do the inverse. Before before I do the inverse, what's the domain of this function? What x values can this function take? Everything. Remember, the only time you're going to have a domain restriction is if it's a square root or if there's an x on the denominator. Neither of these is this case. What's the range?
All real numbers.
So from -1 to infinity. Is that okay? It starts at -1, goes up. That means if I am doing my inverse, what's the domain of my inverse? The domain of the inverse is the same as the range of the original function, and the range would then be all real numbers. It just switches. So let's plot that. Any questions so far? Yes. I don't. Will you look at your homework really quick? Is this also? It is on the test, so I want you to do it on the homework and on the notes. The domain and range. I would like you to add that instruction to your homework, please. On questions 13 through 10, I found 9 and 10, by the way, they're right there.
And they're still worth extra credit.
So on those 4 problems, I'm sorry, the numbers are all zero. Please add find domain and range of the original and of the inverse. Those 4 graphs. On the test, you'll have a graph and it will have domain, range, and you have to list everything. On the review, it looks that way as well. So I have my XY chart, right? Now let's do the inverse chart.
You have to do the inverse chart?
Yes. Unless you want to find the inverse equation. But Brandon, if I'm asking you to do it, that means you have to. So moving on. How do I find this? This is inverse. Everywhere, you switch them. So 7, 1, -1, 1. 7, 1, 2, 3, 4, 5. Okay, so let me backtrack a little bit. If you can just switch them without rewriting it, do you have to rewrite it? No. Is that your question, Brandon? If you can just look at this and say, okay, well now that's my x and that's my y, I don't care. It just says graph. I rewrite them because I make mistakes easily. So if you're prone to making a mistake, it may be worth your time to write it down. But really, I just want your graph on the chart. So do whatever you have to do. Is that fair? Thank you. Okay, so 7, 1, 1, 2. No, I screwed up. 7, 1, 1, 2. -1, 3. 1, 4. And 7, 5, yeah. Okay. Is this one a function?
No.
No. Do I know the equation in this graph? No. I probably could figure it out relatively easy, but I don't really care because the goal is just to graph. So let me backtrack one more time. This is not necessary. This you have to write down, yes. Moving on. Okay, really quick, let's finish this up and then you can work on your homework for the next time. So consider the function f of x equals x minus 2. Is there a domain restriction? Anytime there's a domain restriction is if there's a square root or if there's an x in the denominator. Is one of those 2 things have to be considered?
Yes.
Yes. So what's the domain of this? The domain is x has to be greater than or equal to what? 2. Why? I skipped a step. If you need this step, please write it down. My domain happens because x minus 2 has to be greater than or equal to 0, right? So if I were to solve for x, my domain is x is greater than or equal to, not 0. That's the domain, right? Is that okay? What about the domain and range with the inverse function? What? Yes, because it asks for the range. So to find the inverse is domain range. Yeah, so x is greater than or equal to 0. And y is greater than or equal to what? 2. You just flip them. I'm really struggling to understand. Like, are you guys with me? Are we good with this? Okay? Oh, except for what is f prime? Just kidding, I answered the wrong question in on the spot. So x is greater than or equal to 0, y is greater than or equal to 2. That should go here. Go back to here. What is the inverse? How do you do that? X equals the square root of x minus 2. That's 2y. And then x squared equals y minus 2. Y equals x squared plus 2. Now the interesting thing that would happen here, if I were graphing this, there's a domain restriction, right? Because of the original function, it's forcing this to be a domain restriction. You don't have to graph it, but just watch mine. I'm using this, and this is a whole lot of ugly. I'm sorry. Hold on. Okay, what did we say this was? This was y, or x squared plus 2 equals y. And then this was x and y is greater than or equal to 2. Okay. So if I were to graph this, how do I graph the original square root function? It looks something like this, right? That's the original function. Now, if I were to take the inverse of this, would I have the entire parabola? Because of the domain restriction we set on the original function, when I flip it, this is the entire parabola, but does that match the domain that I said? No. So I would get rid of that part of it. So that's what the inverse would look like. So when you take the inverse of a square root, you only have part of this parabola. Does that make sense? Likewise, if you have the entire parabola and take the inverse, you're going to have the entire parabola on its side. It just won't be a function. I think we're almost done. Excuse me. Is f prime a function? Is this maroon one a function? Yes? Why?
That's a vertical line.
You said that. Okay, so the last thing we have to do for each function, find the inverse and the domain and range of the function and its inverse. Determine whether the inverse is a function. So there's a lot to do in these last two problems. So the very first thing I want to do, let's find this is the function, let's find the domain. And the range. What's the domain of that function? On your own, try it. Just of it normally. The domain would be x has to be greater than or equal to what? Good. You said that, but you just want to point. X has to be greater than or equal to -7. And I got that by looking at you have to indicate what the domain of the function is. Okay? So there's a lot of parts to this problem. Okay, that means the range, has there been any left or up and down shifting? No. So the range of y is what? Greater than or equal to 0. Good. Now, let's talk about the inverse function. To find the inverse, it's going to be x equals the square root of y plus 7. Square it. And then what? Would be x squared minus 7. This is one of those examples where it would look like a partial parabola, right? What would the domain be? X has to be greater than or equal to 0. You still call it X even though like, you're just taking this part of it and moving it here. Hold on.
Why can't you always know that X and T are flat?
Brandon. And then for the range, or do what? I already gave my answer, Brandon. Okay, we've done everything. For the function, find the inverse of the, and the, For each function, find the inverse and the domain and range of the function and its inverse. That's a lot to take in. Did we do all of that? We found the domain range of the first, we found the inverse, we found the domain range of the second. The last thing we have to do is this a function? Yes. Okay, last one. What's the domain? Now this is, if we were to graph it, a parabola, right? What's the domain of the function?
What x values can a parabola take?
Any, good. I'll remember. What's the range? Has there been any up and down movement? Yes, so in this one, my range is y is greater than or equal to what? 2? It's moved up 2? Is that alright? Because of this plus 2 right here, it's moved up 2. So I'm going to say y is greater than or equal to 2. Yes. Because there's no value in here that x can't be. If you're looking at the parent graph, it goes left forever, it goes right forever, but x can't be. But it's the y values, that there's nothing down here, and even like that plus 2 shifted it up too, so it's like that. No, it's further. Yep. That short period. You take care of those two questions. Okay. So what's the domain of my inverse? X is what? And the range would be? Okay. And define the inverse? X equals 2y squared plus 2. Now what? Subtract the 2, so x minus 2 started for the subtract the 2 equals 2y squared, then what? Okay, divide by 2, then what? So y equals what? Plus or minus the square root of x minus 2 all over 2. Is this a function? So this is for my answer, right? Is this a function?
No.
No, because of the plus or minus
Square root, right? This function looks like this. So is it a function? No. All right. You actually have 25 minutes to work. I need you working the entire time, please. Thanks for watching. Peace out.